now when I say that C1 is the point of local maxima, so whenever you have the point of local maxima, the function should increase and then it should decrease on the right hand side of that point. So you should this thing should come in your mind, okay, whenever you are seeing that. So you will see that whether it's a point of local maxima or point of local minima, the point will be always a critical point. That is number one you have to remember, okay. So in the question, if you are asked to find out the local maximum and local minimum value of the function, then first you need to find out the critical points, which gives us the point at which the function is attaining its local maximum and local minimum value function, okay. This is one thing. Now if C is the point of local maximum value of the function, then what should happen is function is increasing, okay, on the left hand side, and then it will decrease on the right hand side, okay. Now we know that when the function is increasing in the interval a to c1, the function is increasing, right? So when the function is increasing, then we know that f dash x is greater than 0 for increasing function. So that topic we had already discussed in the previous section, okay. And when a function is decreasing in the interval c1 to c2, then you will see that within this interval, if you take any point, f dash x will be less than 0, negative, okay. So you will say this is how we are going to apply the derivative to find out the local maximum and local minimum value of the function. So if it is a point of local maxima, then on the left hand side of the point, f dash x will be positive, okay. At any point if you take, the f dash x will be positive since it is increasing in that interval, right? And on the right hand side of c1, okay, within this interval if you take any point, okay, so then the sign of f dash x will be negative because in that interval the function is decreasing. Is that clear, right? So when we talk about the interval, you cannot take the interval as your c1 to be. You have to take the minimum interval, okay. Local, we are talking about the local maximum and local minimum, okay. So it is like this. So this is how we are going to apply derivative in finding out the point of local maximum value of the function, which gives us the local maximum value of the function, okay. So first you will find out the critical point, and then you will check that critical point is it local maxima or minima. So for that you will take one point on the left hand side and check the sign of f dash x at that point. If it is positive, then it means it is increasing, right? And on the left hand side you take one point and check the sign. If it is negative, it is decreasing, right? So increasing, decreasing, increasing, decreasing. So this graph is formed, which means C1 is the point of local maximum value of the function, right? Similarly, when you have point of local minimum value of the function, it is again a critical point, okay. So you will get this. Now to check whether this is a point of local minimum or local maximum, it is not possible for us to every time draw the graph of the function, right? So theoretically we'll try to check, okay. So if it is local minimum, then how your graph should be, it is decreasing on the left hand side and it's increasing on the right hand side, okay. So on the left hand side you take a small interval, and within that interval you take a point, right, and check the sign of f dash x. So you will see that it is negative, which means the function is decreasing. And then you take any one point from this interval, small interval, and you check the sign. Now in this interval the function is increasing, so which means f dash x is greater than 0, okay. So this is how we are going to apply derivative. So if a sign of f dash x is changing from positive to negative, okay, then this point is the point of local maximum value of the function, right? And if the sign of f dash x is changing from negative to positive, right, then this point is the point of local minimum value of the function. So this is how we are going to check the maximum, local maximum and local minimum value of the function, okay. Okay, so this method is called as first principle method, because first derivative test, okay, because we are applying first order derivative to find the local maximum and local minimum value of the function, okay. So this is what we are going to do. I'll quickly write it here, okay. So this is first derivative test. Okay, first derivative test. Okay, so now in short I will write, okay, C is the point of local maxima if f dash x is changing its sign from positive to negative. Okay, so C is the point of local maxima if f dash x is changing its sign from positive to negative. Now you should know the C is one of the critical points. So first of all, you have to find the critical point, because point of local maxima and point of local minima is always a critical point. Okay, so if you get more than 2 critical points, then you have to now check which critical point is the point of local maxima and which is the point of local minima. For that, you will apply first derivative test, right? So if f dash x is changing its sign from positive to negative, then we say that C is the point of local maxima. Okay, number 1. And number 2, if f dash x is changing its sign from negative to positive, okay, then C is the point of local minima. So this is first derivative test. So using first order derivative, okay, so this is how we are going to find the point of local maxima and point of local minima. So for this, we will take one example. So we will solve this example. Find all the points of local maxima and local minima of the function f given by fx is equals to x cubed minus 3x plus 3, right? So you have to find the point of local maxima and point of local minima for this function. Now here you are asked to find out the point of local maxima and point of local minima. So you only have to find out the point of local maxima and point of local minima. You don't have to find out the local maximum and local minimum value of the function. So read the question carefully, and corresponding to that you have to solve that. Okay, so now we know that. Now here I will solve this question fully, so you will always follow the same pattern, okay, because it is very much easy. Okay, so we know that the point of local maxima and point of local minima are always the critical point. Okay, so first of all we will try to find out the critical point, and we know that at the critical point f dash x is equals to 0, because at slope of the tangent is equals to the slope of x-axis, which is equals to 0, right? So you will find out this. F dash x is equals to fx is given as this, so f dash x you find out, so that will be 3x square minus 3 plus 0, right? So we have this f dash x is equals to 3 into x square minus 1. So this you can write it as 3 into x minus 1 x plus 1. So you can do this. Okay, so yes, so you can write this, right? Okay, after this, now for critical points, now we have to find the critical points, and we know that at critical points we have f dash x is equals to 0, right? So we have 3 of x minus 1 into x plus 1 is equals to 0, which means x is equals to 1 or x is equals to negative 1. So we get 2 critical points, right? So we get 2 critical point, 1 and negative 1. Okay, so now how we are going to do is, now one of the critical point will be point of local maxima and one will be the local minima. So you can get more than 2 critical points. So at each critical point you have to check whether it is a point of local maxima or point of local minima. Okay, so to check this one, okay, so you are going to do this. Okay, now our interval, when your interval is not specified, your interval is set of all real numbers. Always remember that. Okay, so which means real number means negative infinity to positive infinity. Okay, so it is somewhat like this, negative infinity to positive infinity. Okay, and you get 2 critical points, negative 1 and positive 1. So always remember to write the smaller number on the left hand side. So you will write it like this. Okay, so if you write 1 over here and negative 1 over there, then it's incorrect. Okay, So it is a number line, so the smaller number always comes on left. Okay, so you have to take your intervals as this. Now you have to check whether this is the point of local maxima or local minima. Okay, so for that what you're going to do is you take any one. Okay, -1, you have to now check this, right? Okay, you write it like this. You take one point on the left hand side of -1, so in between this, so you can take any negative number. So I will take here, this is -2, right? And you take one point here, you can take 0. Okay, so 0, right? It should be in between this. Okay, so you take 0. Then you will check the sign of, here this is f dash x is equals to, what was it? 3 into x minus 1 into x plus 1. So you don't have to find out, or you don't have to calculate the actual value of f dash x at that point. You just need the sign. Okay, you just have to know the sign of f dash x at that point. So I'm not going to do the whole calculation. So when I put -2 over here, so this is a positive term, 3 is a positive term. So when I put negative term over here, so -2 minus 1, so that is a negative term. -2 plus 1, so that is negative. Okay, so this is positive, right? And here when you put 0, so this is a positive term. Okay, 0 minus 1 is a negative term. 0 plus 1 is a positive term, so this is negative, which means f dash x is changing its sign from positive to negative. Is that clear? When you have this, f dash x is changing its sign from positive to negative, then C is the point of local maxima. Okay, so therefore you get this. Next you have to do the same thing for this 1. Okay, then you check the sign. Okay, this is the number 1. Then you continue here. Okay, then you will take for 1. Okay, so then you will take 1 point on the left hand side of 1, that is you can 0, and you take 1 point on the right hand side of 1, you can take 2. Okay, so at 0, 3 is positive, this is negative, and this is positive, so you get negative term over here. Okay, and at 2, 3 is positive, 2 minus 1, it's a positive term. 2 plus 1, 3, it's a positive term, so this is positive, right? So at 1, okay, f dash x is changing its sign from negative to positive. If it is changing from negative to positive, then you say that C is the point of local minima. Okay, so then you can sum up. Therefore you can say that C equals to what was that? Okay, -1 is the point of local maxima, and C equals to 1 is the point of local minima. So this is the complete solution to this question. Okay, now if you are asked in this way, find the local maximum and local minimum value of the function. If your question is this, so then you have to find the point of local maxima and minima. That's so obvious. Okay, then you have to find out f of -1. Okay, because -1, at -1 the function is attaining its local maximum value of the function. So you find out f of -1. So f of -1 means here you have to put -1 whole cube minus 3 into -1 plus 3. So this is -1 plus 3 plus 3. So this is 6, 5. Okay, so 5 is the local maximum value of the function. So this is how you write. Okay, similarly then you find out f of 1, okay, which is the local minimum value of the function. So this is how it is to be done using first derivative test. Okay, so I will repeat it. It's quite simple. If you are asked to find out local maximum and local minimum value of the function, or just point of local maxima and point of local minima, what you have to do is, first of all, you will find out all the critical points, because we know that the point of local maxima and point of local minima are always the critical points. Okay, and then to check which critical point is the point of local maxima and point of local minima, you will take that critical point, okay, and you take 1 point on the left hand side of the critical point and 1 point on the right hand side of the critical point. Check the sign of f dash x at these points, okay, If f dash x is changing its sign from positive to negative, then that critical point is the point of local maxima. Okay. If f dash x is changing its sign from negative to positive, then that critical point is the point of local minima. So this is how this question is to be done using first derivative test. Okay. Now we have one more method, that is second derivative test. Okay. Now you should be very much clear with first derivative test. Okay. Both the methods you should know. Second derivative test is much easier to find out the point of local maxima and local minima. It will take less time to solve, but sometimes for some questions, okay, second order derivative test is not applicable. So in that case, okay, you have to apply first derivative test. So I recommend all of you to be sure that you will be able to solve this type of question using first derivative test. This is the basic method you should know. Okay. Second derivative test is applicable for some questions but not applicable for some questions. So at that time you should be able to apply first derivative test. Okay. So now we will define second derivative test. Okay, I will just write down. Okay, C is the point of local maxima if f double dash of C is less than 0. Okay. Number 2, C is the point of local minima if f double dash of C is greater than 0. So this is second derivative test. Okay. So in first order derivative test, what we have to do was, first you will find the critical point, and to check whether this is the point of local maxima or minima, what you did, you take one point on the left hand side of that critical point and one point on the right hand side. Then you check the sign of f dash x at these 2 points. Then you check whether it is changing its sign from positive to negative or negative to positive. Corresponding to that, you get the point of local maxima and point of local minima, right? Whereas in case of second order derivative test, it's quite simple. Okay, you have to find out the critical point. Up to that, it is same. The critical points are the point of local maxima and minima. So you have to find the critical points, and to check whether the critical point is the point of local maxima or minima, you will find out f double dash x, that is, you will find out the second order derivative. Okay, and then you will check the sign of f double dash x at that point, critical point. If it is negative, if the sign of f double dash x is negative at that point, then that point is the point of local maxima. Negative, if it is negative, then it's the point of local maxima. If it is positive, f double dash x is positive at that critical point, then that is the point of local minima. Okay, so quite simple. Now we are going to solve the same question using second derivative test. This is how we had solved using first derivative test. We got the critical points, then we had taken one point on the left hand side and one on the right hand side of the critical point. We checked the sign of f dash x at that point. Alright, so it's quite lengthy. Okay, now in case if it is if you are going to solve using second derivative test, then it's much easier. Okay, this is how we are going to do. Okay, so you have to find the point of local maxima and minima for this function. So for that, first you will find out f dash x. It's quite same. Okay, so that is 3x square minus 3. Okay, so always you simplify before finding out the critical point. Always simplify the first order derivative. Okay, so this is equals to, you take out 3 common, x square minus 1, so that is 3 into x minus 1, x plus 1. Okay, right? Or else you can, since in second order derivative test, you have to find out the second order derivative. Okay, so now you find out critical point. For critical point, okay, you have f dash x is equals to 0. So we have 3 into x minus 1 into x plus 1 is equals to 0. Okay, so we have x is equals to 1 and negative 1. So we get two critical points. Okay, now to check which one is a point of local maxima and which one is point of local minima, okay, you have to find, you are going to apply second derivative test, for which you have to find out the second order derivatives. F double dash x you have to find out. So this is f dash x. You further have to differentiate it. So now you'll see which one is easier for you. This one is easier to differentiate it. Okay, so you see, this is it easier, or this one, or this one, whichever you want, you can differentiate that. So f dash x is same. It's the simplified form of f dash x. So f double dash x is equals to, you differentiate this, so that is 6x, right? 6x minus 0 is 6x. Now you check f double dash x. At first you check at 1. Okay, so this is equals to 6 into 1 is equals to 6, which is positive, right? Now if f double dash is positive, then this is the point of local minima. So 1 is the point of local minima. Okay, then you find out the sign of f 6 into negative 1. So this is equals to negative 6, which is less than 0, right? So negative 1, okay, f double dash sign is negative. So negative 1 is the point of local maxima. Okay, so you see, we get the same answer by using these two methods, first derivative test and second order derivative test, right? But in some cases, okay, second order derivative test is not applicable if f double dash x turns out to be 0. Okay, if it is non-zero term, then it's fine. Okay, but sometimes what happens is, when you apply second order derivative test, then when you put the critical point, you will get f double dash x is equals to 0, which means second order derivative test is not applicable for that function. So you have to apply the first derivative test. Is that clear? So that's why I was telling you, you have to be thorough with first order derivative test, because in some cases second order derivative test is not applicable. Okay, so you have to be this first order derivative test is kind of backup. Okay, so when second order derivative test is not applicable, you should use first order derivative test. So you remember these two. Okay, so today this theoretical portion is quite lengthy, which makes you like this topic is a very tough one, but it's not so. Okay, now if you solve questions, then you will feel how easy it is. Okay, and this is one important topic from this chapter. So all these questions, increasing and decreasing function or local maxima or minima, this frequently come in exam, which will be of 4 marks. Okay, so and it's quite simple. So today you will do this exercise 6.5, question number 3. Okay, so in question number 3 you are given few functions. Okay, and for these functions you will find out the local maximum and local minimum value for these function using both first derivative test and second derivative test. So you will use both of this and to solve one question. Okay, question number 1, first you find out the local maximum and minimum value using first derivative test, and then same question is to be repeated with using second derivative test. Okay, so you will do question number 3 by using both first derivative test and second derivative test, right? And after this lesson you will find the notes on this local maximum, local minimum value of the function, and maximum value and minimum value of the function. The definitions I will just give you so that you can recall. Is that clear? Okay, so today with this I will stop here, and still we are left with few more topics on the same topic. Okay, local maxima and minima, that we will continue in the next class. Okay, so today for the time being you should only study first this derivative test and second derivative test to find out the point of local maxima and local minima, right? Okay, thank you. So this question you have to do, question number 3. Thank you.